You can see that.
Yeah, it's good. Thank you.
Okay. So yes, thank you very much for inviting me to present. It's a great opportunity to raise awareness about hand-down vibration, and I'll try to make this into a more educational type presentation, and really go down the route of understanding the root cause of exposure in businesses like yours in the metal forming industry. So just a little bit of background about the actual product and how the company got started. So we designed and manufacture wearable technology specifically for hand-down vibration syndrome. The glove picks up acceleration at the palm of the hand, so it understands how much your hand is vibrating. And we also pick up grip force, so we understand how hard you're squeezing on the tool. And then on the back of the hand, we have the alert system that tells people when to stop, when to take a break, when to do a job rotation before it's actually dangerous to their hands. And at the end of the day, the operator would plug in the glove into a docking station that would transfer the data to the cloud, and you would have a dashboard similar to the one that you see on the slide here. So that's really all I'll cover about the product. And now I want to go into the details of HAVS and how everything started. I've been interested in this topic since 2015 when I was working for a large aerospace manufacturer, and very quickly realized there's really nothing on the market right now that can help people prevent hand-down vibration syndrome. Because hand-down vibration syndrome is a debilitating condition that is permanent. So the only real solution is prevention. So I've been going around the UK trying to raise awareness of hand-down vibration and prototyped some devices initially, and now we're actually fully on the market since 2021, and we have a number of customers in the UK and in Canada. And actually, I'm presenting to you from New Orleans, from USA. I've been invited by the National Safety Council, which is the equivalent of the Health and Safety Executive in the UK, to come in and raise awareness about HAVS and present about the technology. So hand-down vibration syndrome is, like I said, a debilitating condition developed by people that work with vibrating tools. It is permanent, so once the symptoms are fully ingrained in the hand, there's no cure for it, but it is preventable. So if you have the right technology to do some measurements, and if you implement control measures for your workforce, then you can prevent hand-down vibration syndrome quite easily. The symptoms are branch into three separate stages. So the first stage would be neurological symptoms. You start feeling tingling and numbness in your fingertips. More advanced cases start feeling pain in the fingers. And then you would move on to the musculoskeletal symptoms. So you would have damage to the median nerve that relates to carpal tunnel, and you will be having trouble moving your wrist, and it will feel painful. And then the last one, it would be vascular symptoms. So vascular being circulation problems and white finger, as it was previously called in industry. So you don't have blood in your fingertips, and it's very hard for you to move them. You won't be able to grip anything from, you can't button your shirt, you can't hold a cup of tea, can't play with your kids anymore. So it's a very debilitating condition that affects people in a very serious way. So like I said, musculoskeletal, neurological, and vascular being the last stage where people, very severe cases actually end up in amputation. So you wouldn't want to lose your fingers because you are not aware of the risk. And just to re-emphasize on this, once the damage is done, normal daily life is no longer possible for people with hand-down vibration syndrome. So that's how the condition affects the operator. Now, how does the condition affect your business? Employees, obviously, that develop symptoms will have to stop working, at least on that specific task. Projects might be delayed. You might lose opportunities because you haven't really dealt with hand-down vibration from the beginning. There's a risk of reputation. People don't want to work for companies that don't protect them. Injury claims can create bad publicity. And obviously government fines are public and will be, can be viewed by anyone on the government website. So if you do get fined, everybody will know. And then financials, of course. So some statistics that I've gathered recently, specifically for the webinar, there is a page on the HSE website that shows all the companies that have been noticed by the HSE to resolve their HAVS problem. And already this year, 24% of them were fined. The average value of a fine is 250,000, and then you would have to pay worker compensation every year as well. So the bottom line is doing something about HAVS can be quite cost efficient and very easy to implement. And it's much more expensive not to do anything about HAVS. Our product and the initiative of the solution is really focused on control measures. So that's what the HSE wants to see in an inspection as well. No matter what technology you have implemented, if you don't do anything with the data, then you still are in trouble with the HSE, because the HSE, and rightly so, are focusing on control measures. So is everybody aware within the organization that hand-down vibration is an issue? Do you select the right tools for the job? Do you have the right consumables for those tools? Are you changing them frequently? What's your job rotation like? Are you making someone work with vibration for the whole day, or do you job rotate sometime during the day so that nobody works with vibration for the whole duration of their work shift? Do you advise people to have good blood circulation? So, stretch your hands, things that you can do, for free without, spending money on any technology at all. Stretch your hands, do have regular breaks, make sure your hands stay warm, especially now when weather is getting colder and colder. Make sure the handles of the tools are not cold when you grip them. And then continuously improve by checking and doing measurements to understand if the control measures are actually working. Now, if I would have something that you can take away from the presentation is this. So this is the hierarchy of control, and especially the HSE really likes this approach of elimination. So process elimination would be the first step that you would try to take towards mitigating HAVS. Can we do things differently? Can we get better tools that don't actually expect people to be exposed to vibration? Can we do things differently so we don't expose people to vibration at all? If that's not possible, then the next thing would be the fundamentals of control measures on the previous slide. So is everybody aware of the risk? Can we put in place engineering controls based on actual data within the work environment, so we know how to train the workforce to work more efficiently and be less exposed? And then lastly, if everything else was exhausted in terms of options, you would rely on PPE. So you would try to limit exposure with PPE. However, there's no really effective PPE on the market right now for hand-down vibration specifically. And I know there are anti-vibration gloves or vibration dampening gloves out there, but there are studies published, and I can share them with anybody interested after the webinar, that clearly show anti-vibration gloves are not very effective, and usually they tailor anti-vibration gloves for specific tools. So you can't just get an anti-vibration glove and use them with all the tools that you have. The main thing to understand about anti-vibration gloves is that they bring the frequency of vibration down to where the weighting factor is actually higher. So you could actually be exposing people a bit more to HAVS because you're using anti-vibration gloves. It's true that the amplitude of vibration is lower, but it's the frequency that brings the weighting factor to into play. So be careful with anti-vibration gloves and always try to go for elimination of the risk. Now, our solution was built so that you have the right data to be able to make those decisions. And the core of the product is formulating control measures. We have, like I said before, the gauntlets with the electronics assembled in the glove that measures vibration and tells people in real time what their exposure is. And then at the end of the day, the operator would plug into a docking station and you can have all the data available. We've automated the assessment process of who's actually exposed. So if somebody comes in with an exposure that's over the action value, the managers will get an alert on email straight away saying you've just had someone today exceeding the exposure action value. This was the process that they were working on. Please go in and have a look at the data and try to formulate some control measures so we can reduce that exposure. And really the best thing about technology nowadays is that sensors are so small and you can really comfortably fit them on the palm of your hand. You won't even notice they're there. And you can get to the root cause of the actual exposure. So was it the tool itself that's maybe out of calibration or is too old, should be replaced? Is it the consumables that need to be replaced? Is it the grip? We collect data on grip for, so maybe the operator's gripping too hard. Was it their posture? And you know, are they resonating with the machine? All of that can be easily mapped out on the dashboard if you have 5 to 10 days of data for each operator. Now the system is very easy to use, and we have 4 hardware elements and a software element. So the gauntlet is ambidextrous and was designed as a liner glove, so you should wear it inside your normal PPE. And then we have the IGES unit, which is the measurement unit that is assembled in the glove and can be disassembled, can be shared between operators. And then we have the ID tag that's unique to the individual, identifying who's actually working on that process. Because obviously anthropometric data of every human being plays an important part of how they absorb vibration. A smaller human being compared to a larger human being would absorb vibration differently, and that's captured on our profiles on the dashboard. So ID tags identify the operator. You have to scan in the morning as soon as you start your shift. You start measuring straight away, and then you go do your work. You don't have to carry the ID tag with you. You can leave it in your locker, or you can take it with you if you want. And then at the end of the shift, you would come back to the docking station, plug the gauntlet in, and that's the end of your process as the operator. And then the process of formulating control measures would start if you are overexposed. So, like I explained before, the only step is connect the ID tag to the sensor unit, so we know who's actually generating that data, and then connect to the docking station after work. And so you have to just wear it and work. That's what we say. Wear it and work. There's no disruption to the process. There's no tool tags to be, tool tags to be scanned or anything like that. You just wear it. You'll measure everything you do, and then at the end of the shift, you would plug them into the docking station and have all the data available. Now, an example of how this would be implemented and how we focus on control measures on the slide here. If you have, let's say, 20 operators that you've identified as exposed to vibration, we would recommend somewhere around 5 measurement units to be deployed, and ID tags for each operator, so we can capture each operator behavior and exposure. You would gather between 5 to 10 days of operator-specific data on each tool or process. You would then establish control measures, and if you don't have an occupational hygienist or health and safety manager within your organization, we have consultants that you can work with to establish control measures, and really map out the risk. So once that's done, you would understand how many people are actually exposed, what processes are actually causing the risk. We would try to go through the hierarchy of controls, and then at the end of the process, you would either roll out more equipment to protect people that need protection in real time, because you are not able to eliminate the risk, or scale down the hardware that you've already got, because you don't actually have that many people exposed. So in essence, that's the system and how it works. We offer online support and remote firmware updates to the docking station. So every time you plug into the docking station, we know what's happening to that specific unit. Workforce training and HAVS workshops, we also offer those. So we can come into your working environment and do a workshop with your workforce to understand what they can do for free to stay protected. And obviously data analysis and reporting is being automated on the HAV-Sentry dashboard. So I would like to turn this into more of a discussion and get feedback on how you think you can implement this, or if you think it's useful. Take your questions and turn this into more of a discussion, because obviously we're just a small group today on the webinar. Thank you.
Thank you, Andre. That was very interesting. If I can kick off the questions myself, why everyone else is thinking of some perhaps. So I've got a couple of questions. The first one is, how long does it actually take for somebody to actually see damage?
Yeah, so it's a good question. The average that we know about from scientific papers is somewhere between 1.5 years and 2 years, and that's daily exposure. So if you would work daily with vibration for even as little as 2 or 3 hours, you would start developing symptoms within 1.5 years, 2 years.
Okay, and is there any particular tools that are more prevalent in causing it than others, or is it any power tool that gives vibration?
No, so obviously there are, higher vibrating tools and lower vibrating tools. Nowadays, manufacturers are actually doing a really good job of making tools less and less vibration prone, or hand-on vibration prone. But obviously construction is probably the highest exposure. So things like jackhammers, road breakers, things like that. In the manufacturing industry, I think grinders are the highest exposure tool that we've identified so far with our data and within the environments that we've measured so far. Polishing is also a high risk operation. Metal cutting, so when you cut metal with any type of tools, that's definitely some heavy vibration. Rivet guns, they're really big on vibration as well, especially old ones. And yeah, there's a lot of vibration going on with just holding pieces of equipment that vibrate as well. So it's not just the tools itself. If you're holding something that's vibrating, and you also get exposed. And I think we're probably one of the only companies that can actually pick that up as well, because we measure at the palm of the hand. Everybody else has to tag tools or understand based on tool manufacturers' data what the exposure is. We don't actually need anybody else's data. We collect our own data. So even if you're touching something that's vibrating, we can still help.
That's interesting. And one more from me then.
Yeah.
If I can remember what I was just about to say. Oh, yeah, I thought it was interesting what you said about the glove will actually detect when the power tool is old and needs to be replaced. Is that correct?
Yes, yeah, that's right. So that we gather data on frequency, the frequency of vibration. So vibration has two elements. You have vibration amplitude, so that's how hard you're vibrating, and then we have vibration frequency, and that's how fast you're vibrating. And if you look at the data, we've just done some tests with some brand new tools here at the NEC in New Orleans. And we can see on the dashboard very smooth profiles of vibration on the frequency side. Now, if that was an older tool, you would see spikes all over the place, and you can tell immediately, oh, there's something wrong here. And some of our clients actually use the gloves to build business cases for replacing existing tools. And I think this is a valuable tool.
Yeah. Yeah, that's interesting. It's also interesting what you said there about just maybe holding a piece of equipment that's vibrating. So in a lot of cases, people presumably don't even know they're at risk because they're not using a power tool, but they're still coming into contact with vibration.
Yeah, that's right.
Yeah, okay. I'll stop hogging the questions now. Does anyone else have a question for Andre?
Regarding, we use a lot of high frequency tools, Andre,
Okay.
which are two-handed tools. So basically, you're holding the shaft of a 6-inch grinder, and also the handle where the switch is.
Yeah.
Where would you likely to see most? I mean, certainly I know, but where would you certainly feel most of the vibration, through the handle or through the shaft on a high frequency tool?
So let me get this straight.
How would you measure that with one-handed tag? That's pretty much my question. Sorry.
Yeah. So let me get this right before I answer it. So you're holding the shaft with one hand, then you're holding the tool that's vibrating with the other hand.
Yes.
Okay.
So the whole machine will vibrate at some point where the shaft is rotating and where your handle you're holding. My question is, if you're wearing one tag, are you likely to get a different reading from one end of that grinder to the other end of the grinder, or?
Yes, I think you would, yes. And
they're offset grinders, you say?
Yes, that's right. And so our approach in the past, we've had cases where people were unsure which hand is actually more exposed.
Yeah.
So the approach there was you would need two gloves and two ID tags.
Right.
And you would do the analysis in terms of comparison between the hands.
Okay.
And then once you know which one is more exposed, then you revert back to only one glove, one ID tag.
Yeah.
And then you continue that way.
Yeah, I see. Yeah, okay. Just going back to your gloves, I'm talking about anti-vibe gloves.
Yeah.
I've been in the industry for 35 years and I've not found absolutely anything that works. Nothing whatsoever.
Here we go. Yeah. So yeah, it's quite a misconception, especially here in the US. Everybody thinks they work. Everybody likes them so much.
No, I've like I say, 35 years, and I've had millions, well, not millions, but loads of companies try to sell me gloves that tell me they're the best next best thing. We've trialed everything, like I say, for all them years, and I've never found one. And now I can tell them that nothing actually works because we've tried everything. So
yeah,
now
it's a very tricky thing to get right, because you're essentially introducing layers of different types of material between the operator hand and the handle.
Yeah.
And you need to take into account the size of that hand, how thick is their skin, the muscles, the vascular structure, the bones. Everybody's a little bit unique, so it's so difficult to get that right.
Yeah. I mean, obviously we don't measure it at the moment, but what we do is rotate the staff from doing them sort of jobs and try and get them off as soon as we possibly can, so they're not getting too much exposure. But the key thing is, I think, for all the years I've been in this industry, is I always say to all the fettlers that do that sort of operation, is keep your hands warm.
Yeah,
as you possibly
that's
can.
right.
It's obviously the cold that starts giving them the problems and the vibrations. So.
That's exactly right. Yeah.
Okay. Do we have any other questions?
I think that's it. Is it one quick question. When you were relating to the dashboard for putting your tags in, if we was to go down a route of something like this, so we've got 1, 2, 3, 4, 5, 6 departments across the company, would we look at probably investing in 6 units and, I don't know, 40 tags to be able to give each operator like an ID tag? Would we be looking at a whole package for this?
Yes, yeah, that's right.
Okay, I'm just thinking, do we need one dashboard? Is it, you know, is it huge? Do we have a central area for plugging them all in, or? Well, obviously you've just answered that question, so.
Yeah, no, you would if all departments are in the same location, you can have one docking station and that can take in all the data.
Yeah.
But if you're in different locations, you probably need more docking stations.
Yeah, okay. The next question is obviously the information that's recorded, that is, you said it was sent on an email to the manager or directors or whatever to let people know that they're having too much exposure or the exposure levels are good, or?
Yes, that's right. So you can configure that on the dashboard and receive alerts for, you know, whatever interests you. If it's overexposure, then it's overexposure. If you want weekly reports, you can get weekly reports. If you want daily reports, you get daily reports. And you can choose that on the dashboard once you log in.
Yeah, okay. Yeah, fabulous.
I think on that subject, Andre, that Simon was just mentioning, when you said, you know, you get if the exposure is above a critical level, then it sends an alert. Does that sends an alert to the safety manager? I presume as an email signal. So does it actually alert the operator? Does there something on it shine a light or vibrate or?
Yes, that's right. So it does alert the operator in real time. So as soon as you reach the exposure action value, you would get a visual alert on the back of the hand, and you will get an audio alert as well from the glove, because obviously you might be wearing PPE on top, so you won't be able to see it. But if you can hear it, and then at any point the operator can press the button once and check their exposure and see where they are. There are 3 LEDs that light up gradually as you progress towards the action value. And then if you continue working through the action value, you get to the limit value, which is 5 meters per second squared, or I think it's 400 points. You need to really stop for the day. And the alerts for that are a lot louder and, you know, very, very annoying. You can't ignore them. Like you need to really stop at that stage.
Okay, that's useful, Andre. Thank you.
Yeah.
Sorry, just one question about the lifespan of this device.
Yeah.
So obviously, if we work with heavy stampings, etc., and a lot of rework, and it is a dusty environment,
Yeah.
how durable are they? What we're looking at is like a year, 2 year kind of a period, or?
So yes, I think I have a slide on this that I was expecting. So we offer 12 months warranty for the IGES and the docking station. So for the measurement unit and the docking station, the measurement unit and the docking stations are IP64 rated, so they would resist dust and water contact. The glove itself is consumable, so you can work through gloves and have replacements ready for them. The typical lifespan of a material glove is about 6 to 8 months if you wear protective PPE on top. If you just wear the glove and do the work without PPE, it's probably just maybe a month or 2. So it's a very big difference between wearing PPE on top or not wearing PPE on top. And in terms of the hardware, every time you plug into the docking station, the system is checked for calibration periods and for any damage or any problems with the measurement system. And if you do have a problem with it, it will flash pink, and you need to, we already get notification that this unit specifically has an issue, and we'll replace it straight away at no cost if you're within the warranty period.
All right, thank you very much.
Are there any questions from anybody else? Okay, well, if we're waiting for anybody else to jump in, question I think from me then, Andre, is what's the best sort of means for follow-up then? So for anybody that's interested in this sort of technology and perhaps having a trial or having a demonstration, you know, I came over to see you going back a few months and trial, you know, the gauntlet. It fits very nicely. It's not obstructive in any way. But for anybody that's interested in it, what's the best means to follow up? You know, in terms of perhaps doing a trial or maybe testing the equipment out.
Yeah. So there are a few ways. You can email me directly. The CBM will probably share my contact details after this. You can go on the website. So that's HAV-Sentry.com. I'll probably share, or the CBM could share the link as well with my details. And there's a form there that it says schedule a demo, so you can schedule a demonstration. And what a demonstration would be is essentially some of our team, or myself if I'm back in time from the US, will come to your work environment with a few demonstration units, and we can collect data on the spot there. So it's really like a HAVS assessment in a way. We collect data and we show you what the exposure is for the process that you've picked. And then we can show you how the dashboard looks, how to interact with it, how easy it is to use the actual kit. And we'll give the operators a chance to give feedback on comfort and how comfortable it is to wear, how easy it is to pair and do the work with the glove on.
Okay.
That's good, Andrew. Thank you. Sorry, Derek.
Yeah. I say if there's no other questions, then we'll start to wrap up. But obviously, Andre's told you how you can get in contact. You can contact Derek, myself, or Melinda, and we'll pass on the details. We'll put all the links on to everything we publish and stuff. So there's plenty of way of contacting him. So I'd just like to say thank you very much, Andre. Very interesting presentation on some very important technology, and I think that we can spread the word on this and hopefully get people interested in it. So thank you very much for your time, and enjoy the rest of the stay in the States.
Thank you. No, I really appreciate the opportunity to speak about HAVS, and the CBM is doing really great work, I think, to raise awareness, not just for this, but for other hazards as well. So I appreciate it. Thank you.
That's great. So thanks everyone for joining us this afternoon. Unfortunately, a couple of people dropped out, but obviously everyone's busy. And we'll be publishing soon our next details of our next technology transfer webinar. So it was nice to see everyone today, and thank you very much.
Thank you. Have a good day.